Hi everybody. In this video we will continue working with chapter 12, probability distributions, specifically section 12.2, the binomial distribution. We begin by looking at example 12.6, and it says, a cereal company puts miniature figures in boxes of cornflakes to make them attractive for children and thus boost sales. The manufacturer claims that 20% of the boxes contain a figure. You buy 3 boxes of this cereal. Letter A, find the probability that you will get 1, exactly 3 figures, and 2, exactly 2 figures. So for this, we're going to take a look at the tree diagram. So notice that here we have all the different possible paths. We can get figure, 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 which is the case that would answer part 1, exactly 3 figures. There's only one chance of doing that, and that is equal to 0.2 times 0.2 times 0.2. And this is 0.008. So 0.8% chance. Then we have, for number 2, exactly 2 figures. So let's take a look at this tree diagram and notice that here we have figure, figure, no. So this would be one case where you have exactly 2 figures. Then when you have figure, no figure, figure. So this is another case where we have exactly 2. Then we would have figure, no, no. Then here we would have no, figure, figure. So this is another one. And then here we would have no, figure, no. Here we would have no, no, figure, and no, no, no. So that means that there's 3 occasions in which you could get exactly 2 figures. So that would be 3 times 0.032, and this is going to give us 0.096. So for part B, it says, if you bought 5 boxes, what is the probability that you will get exactly 2 figures? So notice that we don't have 3 boxes anymore, but rather 5. Now, if we do a tree diagram, it would be to extents. Now notice that if you want to get exactly 2 figures, what does that mean? That means that you have to have 2 successes, right? So that would be 0.2 times 0.2, or 0.2 squared. But this also implies that you would have to have 3 failures. So that would be 0.8 times 0.8 times 0.8, or 0.8 to the power of 3. Now, how many different ways can you get this? Well, that depends on how many you have to pick from what total. So it's 5 boxes, and you have to pick 2 figures. So that means 5 combination 2. In how many different ways can we pick 2 figures out of 5 boxes? So does this look familiar? The probability distribution formula. Recall that it's P of X is equal to N combination X times P to the X times Q to the N minus X, where N is the number of trials, X is the number of successes you want to have, P is the success rate, and Q is the rate of failure. So applying this formula here, notice that we would get simply that this is equal to 0.2048. We continue with example 12.7, and it says, a computer shop orders its notebooks from a supplier that has a rate of defective items of 10%. The shop usually takes a sample of 10 computers and checks them for defects. If they find 2 computers defective, they return the shipment. What is the probability that their random sample will contain 2 defective computers? So this is the probability that X equals 2, and we have, in this case, let's use the formula. So N is the trials, the number of trials. In this case, it's going to be 10 computers. We said that X is 2, And then we have the probability of success being 10% or 0.1, which makes the probability of failure equal to 0.9 or 90%. So with this information, we're ready. This would be 10 in combination with 2 times 0.1 to the x, which is 2, times 0.9 to the power of n minus x, which would be 10 minus 2, or 8. And then we plug this into the calculator, and it's going to give us 0.194. Now, the GDC has a function that calculates this for you, so I'm going to show you how to do that next. So what we do with the GDC is that we go to second and vars, and on top of vars, you're going to see something that says distribution. And once you enter that screen, you're going to scroll down all the way to letter A, where it says binomial probability distribution formula. Click on enter, and if you have an old version of the TI-84, you have to put in first the number of trials, which in this case is 10 trials, and then the success rate, which we said was 10%, so 0.1, and finally the number of successes that you want, which is 2. Don't forget to use commas, and then we hit enter. And notice that we get the same answer, right? 0.194 rounded to 3 significant figures. Now, before we continue, I don't want you to forget something important here. We have the binomial probability model or function. N is a number of trials, P is the probability of success, Q is 1 minus P, or the probability of failure, X is the number of successes in N trials, and here is the formula. But what I want you to notice here is that you can get the expected value mu as being equal to N times P, or number of trials times the probability of success. So that would give you the expected value or the population mean. Now the variance is N times P times Q. So number of trials times probability of success times probability of failure, and the square root of that is obviously going to be the standard deviation. We continue with example 12.8. And it says, a study to examine the effectiveness of advertising on the internet reported that 4 out of 10 users remember advertisement banners after seeing them. Part A, 20 users are chosen at random and shown an advertisement. What is the expected number? So what is the expected number of users who will remember the advertisement? So remember that that's mu, and mu is the number of trials times the probability of success. So in this case, it's going to be 20 users times the probability of success, which is 4 out of 10, or 0.4, and this is going to give us 8. So this is the expected value. Now let's take a look at the histogram in this situation. Note that on the histogram, the area in red here corresponds to the expected value 8. For part B, it says, what is the chance that 5 of those 20 will remember the advertisement? So that is the probability that it is 5. So this would be, since there's 20 trials, we want 5 successes. Success rate is 0.4 to the 5, and this times the rate of failure, which would be 0.6, and 20 minus 5 would be 15. So if we plug this into the calculator, it's going to give us 0.0746. And then we have part C. It says, what is the probability that at most, one user will remember the advertisement? So at most one means the probability that X is less than or equal to 1, and this is going to be the probability for X equals 0 plus the probability for X equals 1. So this is cumulative, right? So we can do this using this formula. I'll leave that to you. It should give you approximately 0.000524. Okay, so this would be part B, and this is part C. Now let's focus on part D over here. Part D, it says, what is the chance that at least two users will remember the advertisement? So here we have to be careful because that's the probability of x being greater than or equal to 2. Now, there is a complicated way of doing this, which is adding everything after 2, right? So the probability of 2 plus the probability of 3 plus the probability of 4 plus the probability of 5 all the way to 20. And that would be too long. So what would be easier? Well, the complement of this, right? 1 minus the probability of x being less than or equal to 1. And this is simply going to be 1 minus the number we found in part C. So 1 minus 0.000524, and this is going to give us 0.999475. We finished this video with example 12.9. And it says, a large shipment of light bulbs contains 4% defective bulbs. In a sample of 20 randomly selected bulbs from the shipment, find the probability that A, there are at most 3 defective bulbs. So this is a cumulative function. That is the probability that it's 0 plus the probability that there is 1 plus the probability that there's 2 plus the probability that there's 3. Okay, so I'm going to show you how to do this on the GDC. So for this, we go to second distribution, and then we go down, we scroll down to B, and notice that it says binomial cumulative distribution function. So we hit enter, and again in these old calculators, first we put the number of trials, which in this case is 20, because there's 20 randomly selected computers, then comma, the probability of success, which is 4%, so 0.04, comma, and then third, we're going to put the upper limit of this, and because we're accumulating 0 plus 1 plus 2 plus 3, the upper level would be 3. So then we click on enter, and there you go. So the probability that there are at most 3 defective bulbs would be approximately 99.25%. So for part B, they want us to find the probability that there are at least 6 defective bulbs. So notice that this means the probability that x is greater than or equal to 6. But notice that this would be the probability that x equals 6 plus the probability that x equals 7 and so forth up until the probability that x equals 20. So this would be very tedious. It would be much easier to calculate the complement of this. In other words, 1 minus the probability that x is less than or equal to 5. So we're going to use the GDC to calculate this. So this would be 1 minus, and then we go again to distribution, and we go all the way down to B, which again is the binomial cumulative distribution function. And in this case, we want 20 trials, probability of success 4%, and up to 5, right? Click on enter. So notice that it's 9.77 times 10 to the negative 5.